Yeah, so that's what we're going to talk about today. So there cannot be a radical symbol in the denominator. So we're going to start this today. What else do you need to check off the list? There's 3 things, I think. That was one of them. What was something else? All right, so the outside numbers can be divided amongst themselves, and so 4 over 6 reduces to what? 2/3. Okay, so we definitely have that. What about that x that's on the outside? The x stays because it's nothing else outside with it, right? Okay. What about the stuff that's inside the radicals? What happens with them? All right, so 18 divided by 3 is? Right, these cancel because they're on the inside. Close. Okay, so one of the y's cancel. All right, and again, you go through and you say, is there anything left in this radical I can simplify? So can you simplify the square root of 6? Well, so you try to, and you break it down to its primes, 2 and 3. Do we get a group of 2 out of that? Okay, so we can't do anything with that. What about the y that's inside? Nope. Okay, so that part's off the list. What about the fraction? Can we simplify anything with the fraction left? That's as good as it gets, right? Okay, and so is there a radical in the denominator? Okay, so then this one's done. What we're starting today is when it's not done, when there's a radical down there, and then what we do is something called radicalizing the denominator. And it's not as bad as it sounds. Awesome, I don't know. It does sound awesome, by the way. All right, so a little preview. If we multiply these things together, what would we get? All right, so if you're doing it that way, it would be the square root of what? And x. Okay, so is there a square root of 64? Okay, so if you got to break it all the way down, then fine. But we know what the square root of 64 is, right? Yeah, it's what? And what's the square root of x squared? Okay, so what you want to see here, right, is that if you have a square root, that's the first thing that needs to happen, and you multiply it by another square root with the same radicand, remember radicand, then basically what you're left with is just what's inside. Is that okay? All right, here's something that's bigger than you need to understand, but you will understand it. When we had that 1, how did we simplify 4 over 6? It became 2 over 3, but how did we do it? So, right, we divided it both by 2, right? And so we can do that. Why can we do that? Like, you know, maybe you said, well, it's really 2 times 2 over 3 times 2. So why were we allowed to do that? By the same number. And so why is that okay?
Because it won't.
I mean, you're right there. Yeah, I mean you're basically saying it, but because it's 1, right? 2 over 2 is just 1, and so nothing's changing. Okay, we just make it a little bit simpler to look at. So he's all over it, right? Okay? So the reverse is also true. We're allowed to multiply anything we want to by 1 because nothing really changes. Does that make sense? So if we had, kind of in reverse, like if we had 4 over 6 and we multiply top and bottom by 3, we'd get 12 over 18. So is 12 over 18 the same as 4 over 6, which is the same as 2 over 3? Okay? So that's important. That's a big deal because that's what we're going to have to do to simplify this. Okay? You're allowed to multiply by any form of 1 at any time. Okay? So now we're looking down at that next section, and we're going to look at 33. And I know we talked about this the other day, but I'm going to re-go over it. And I'm going to go over at each step the way you should be thinking about it. You don't necessarily have to write out each of these steps, but this is how you got to think. Okay, so we're on the inside of the radical. 5 over 7 is the only thing you want to look at. Can you reduce 5 over 7? No. Okay, so then you say, okay, well maybe in my mind I'm saying these two are the same. So now you're asking yourself, can I simplify the square root of 5? No. Can I simplify the square root of 7? No. Okay. So 2 of our 3 things of our, when we're deciding if it's simplified are true, right? The fraction can't be done. The radicals can't be simplified, but yet we're not done because of the square root of 7 in the denominator. Okay, so the stuff we just talked about, we're going to create a form of 1 so that the square root of 7 is no longer the square root of 7. So what can we multiply the square root of 7 by so that the radical is no longer there? Square root of 7. Okay, so then now you have to do it both in the numerator and denominator. And our fraction rules say we go straight across. So the square root of 5 times the square root of 7 is square root of 35. And I'm going to write this out for right now. But the whole point of us choosing the square root of 7 is that it canceled. Okay, but right now I'm going to write it out as the square root of 49. But there is a square root of 49. And it's 7. And again, that's the whole point. Otherwise, you pick the wrong number. Okay? You don't have to write this part out. Because you picked this so that it works. Otherwise, you shouldn't have picked it. Is that okay? Now we got to go through it again, though. Can we simplify the square root of 35? No, because it's just 5 times 7. Is there a radical in the denominator? No. Is there any part of a fraction we can simplify? All right, we're done. All right, so you're got to simplify, and I suggest simplifying every chance you get, because you're either simplifying a little bit as you go or a whole bunch at the end. So just looking inside the radical right now, just this fraction, 9 over 20 x squared y, can we simplify anything with just the fraction? No. Okay, so again, maybe you don't want to write this part out, but I'm going to. Because now you're asking yourself, what about the square root of 9 over the square root of 20 x squared y? Can we simplify anything there? Yeah, we can the square root of 9 is what? All right, so then we got 3 left over, right? What about 20? Can we simplify anything with the square root of 20? 5 and 4, so let's check. Maybe we can. So we come over here and say 20 breaks down into 4 and 5 and 2 and 2. So it would be 2. Right, we're looking for a group of 2, right? Okay, so then anything else come out?
Yeah.
Right, because there's 2 x's in there. So then what had to stay inside? More than that. Don't forget the other part. 5y. All right, is that okay? Is there any questions on that? Right, nothing's really that different than what we did on that quiz. I mean, we just simplified a radical, but now we're going through it. What about the fraction? Is there anything we can simplify with the fraction right now? No. What about the square root of 5y? Can we simplify that at all? No. All right, but it's down in the denominator, so that's the problem. So now you're picking a number. Well, don't do 2. The 2's okay. Right, this part, don't get carried away, because this will lead back to that question on 35. This part's okay. You can have stuff in the denominator. You just can't have this symbol in the denominator.
Just do the square root of 5.
A little bit more than that.
5 what?
Does everyone understand why that's the only thing we got to multiply by? And now I'm not going to go through it this time because the whole point was that you picked it so that it worked. Right? Basically, you're squaring that square root, so those are opposites, and so you're just left with the radicand. So, but let's do the numerator first. What's the numerator become? Numerator. No, don't do that. Don't do that. You still got to multiply the insides and the outsides.
So it'd be 3 radical and 5y.
Is that okay? That makes sense, right? 3 times 1, and then, right, there's no other radical to multiply by. Is that okay with everybody? What about what's left in the denominator? A little bit more than that, though. 5y is part of it.
Oh, yeah. 2, maybe 10xy.
Again, you got to go through it, right? Is there anything left in the fraction to simplify?
No.
No. Anything left in a radical to simplify?
No.
Is there a radical in the denominator? There you go, we're done. Is there any questions on that? Right, there's a little, well, more than a little. There's a whole bunch going on.